all the stats and see how many people are there. I'm not able to stream on Amazon. That is fine, but I'm here where it matters on X, on Facebook, and on other worlds on YouTube. Let us just check and make sure. We have two extremely handsome doctors that are joining us today, all the way from the East Coast. We have Professor Avi Loeb. Avi, how are you today, my friend?
It will take an hour to discuss it.
Well, luckily, that's all we get before Michael has to jet off to some other big wig podcast. Michael Shermer, Dr. Michael Shermer, Skeptic Magazine, Skeptic, or Michael Shermer Show on podcast channels. Michael, how are you up there in Santa Barbara?
I'm doing well, thank you. Everything is good.
This has been a really exciting time for astronomy, for astronomers, for physics. It's not too often that you get the world captivated on objects that may be suspicious, they may be malevolent, they may just be ordinary, and we may learn a lot about astrophysics along the way. And today I'm here to hopefully shed some light on this very unusual object called 3I Atlas. And we'll get to what that is in just a moment. We'll start off with a question for Avi, kind of recap what we've learned about this object from the very beginning, but also what we've learned since our very popular live stream, which got hundreds of thousands of views over the summer. And we'll get Michael's take on it too, because he's interviewed some of the leading lights in the field as well. But before we get there, a man's got to pay his bills. I want to first notify my beloved audience that I have a new book, my fourth book, if you can believe it, guys. I've interviewed both of you guys many times, but I've interviewed 22 Nobel Prize winners on the Into the Impossible podcast, and I've distilled their life lessons into two books so far. So my second book is called Into the Impossible, Think Like a Nobel Prize Winner. But Tuesday, my newest book comes out, Into the Impossible, Focus Like a Nobel Prize Winner. And it's basically, as it says, lessons from laureates to ignite your curiosity and your career. So this is really a self-help book for my STEM nerdly friends out there. I hope you'll get it soon. The hardcover is pretty expensive, but the Kindle is only 99 cents for the next week. So there's a link in the description below. Please click it, get it for 99 cents. If you've gotten anything from me, I've sent out over 10,000 of these meteorites to my fans. So hopefully you've gotten a piece of interstellar action as well. That is my favor. I'll only plug it 3 times today, I promise. Okay, now to my good friends. Avi Loeb, joining us from Harvard, Dr. Michael Shermer, the Michael Shermer Show, Skeptic Magazine. We're going to talk today about this interesting object. And I want to start with you, Avi. Can you explain the basics of this object? What have we learned from the beginning? How did it get on your radar, so to speak? And moreover, what have we learned since our very popular live stream back in July? There's been a lot of activity.
Thank you, Brian. First, I would like to say that it's quite rare that there is an event or an object that attracts so much the public attention. And that's extremely important because science is fun. It's not about getting the Nobel Prize. It's about understanding nature. And I'll give you just 2 anecdotes very quickly. One, I received an email from a former US Air Force pilot who said, because of you, he was referring to me, my daughter is now excited to become a scientist and she keeps speaking about aliens. And then a second anecdote, last night I get a text message from one of the racers at the NASCAR car race, and he says, I want to put an image of 3I Atlas, the object that we will talk about, and you on the hood of my car. And you are now a very hot commodity among car racers in NASCAR. And I'm planning to meet him actually within a few weeks. There will be a race in Vegas, and I hope to go there. But these are just examples of how much this object captivated the public's interest. And think about it, if CERN would have discovered the lightest supersymmetric particle, which we did not discover, I should say, and it would have been the dark matter, that would not necessarily inspire a girl to become a scientist and or a NASCAR car racer to put it on the hood. So what I would like to say is that this is a rare opportunity, and that's why I wrote more than 50 essays over the past 2 months on medium.com that discuss how science is work in progress. We don't know what something is. We're trying to figure it out by using data and evidence. And that is a thrilling experience, in difference from politics, where you know the answer sort of in advance, and it has nothing to do with necessarily a way of vetting whether it's real or not. I mean, you just tell a story and try to become popular. So science is different. It's not about us. It's not about prizes. It's about figuring out nature. And the best approach is to be modest and say, we don't know, let's figure it out. Now, with respect to 3i Atlas, it was discovered on July 1st, 2025, by a small telescope, 0.5 meter in size, because it's bright. And if you translate its brightness, you find that it has to have a diameter of somewhere between 20 and 46 kilometers if what we are seeing is a reflection of sunlight from a solid surface. It's not obvious because you might argue maybe there is a cloud of dust. However, if there was dust around a much smaller nucleus, then the dust would be pushed behind the object by solar radiation pressure. We know that from comets. We see a cometary tail behind them. And the Hubble Space Telescope looked at this object on July 21st, took a very high resolution image. There was no tail behind it. We saw glow ahead of the object towards the sun. And I'm actually writing a paper trying to explain that. That was not seen before. It's sort of an anti-tail. Instead of a tail behind the object, there is something preceding it, ahead of it, towards the sun. But the other issue is that if it's such a huge, giant rock, the way that my colleagues are arguing, then it's 1,000,000 times more massive than the previous 2 interstellar objects that were found. An interstellar object is an object moving too fast to be bound by the sun. This object actually is moving at 60 kilometers per second relative to the frame of the galaxy nearby, and also relative to the sun when it entered the solar system. So it's really fast, there is just not enough rocky material in interstellar space to give us such a giant rock once per decade. So either it's a very small rock surrounded by a lot of dust, but then why don't we see the tail? Or it's actually not a rock. And of course, in that case, it might target the inner solar system, and then the statistics has nothing to do with delivery of one rock per decade of such a gigantic dimensions. It's twice as big as Manhattan Island, if we believe the results from the SphereX data. Now, SphereX is a space observatory that actually inferred that there is a huge plume of gas around it containing mostly CO2, carbon dioxide, 95% by mass, 5% is water vapor. And, that implies that it may not be a water-rich comet the way it was. And there was also some data from the Webb telescope that, in fact, inferred very clearly the dominance of carbon dioxide and no tail. But after that, we had some data from the Very Large Telescope in Chile that indicated that in the plume of gas, there is also nickel without iron. And you don't get nickel without iron except through an industrial process on Earth that produces nickel alloys, partly for spacecraft. And therefore, the question arises as whether this was technological in origin. The fact that there is only nickel but no iron observed. Now,
So,
the most interesting anomaly, I should say, besides the size of the object, is that the trajectory is aligned with the planets around the sun to within 5 degrees. That's a probability of 1 in 500 out of a random orientation. And in fact, the previous comet, Borisov, was at a very high inclination, very high angle relative to the ecliptic plane. But the good news is that on October 3rd, that's very soon, within a few weeks, the 3i Atlas, this object, would come within 29 million kilometers from Mars. And there is a camera there called HiRISE on board the Mars Reconnaissance orbiter that could take a high resolution image of it with a pixel resolution of 30 kilometers. And that would allow us perhaps to infer the size of the nucleus and settle once and for all this question of whether it's anomalous in its size, whether it's 1,000,000 times why do we see an object that is a million times bigger, more massive than the previous two? And if
Yeah,
it's if
I definitely want to cover all these aspects. You've covered, just the highlight reel so far. But before we get, down to particular explanations, I do want to get Michael's perspective on this. So, Michael, you've heard about this for a long time. I want to know from your perspective, what is the simplest explanation, like Occam's razor, Wilhelm of Occam? Where should we start? Where do you think, a curious layperson, or even someone who's, more expert than a curious layperson, where should you start? What should be our first supposition from your perspective?
Well, Bayesian, that is to say, let's put some probabilities on it. No one would ever put a 1 or a 0 to it. So 100% it's extraterrestrial, or 0% it's extraterrestrial, by which I mean technology. So somewhere between, let's say, 1 and 99, or 0.01 and 99.9. Let's just put it that way. So we're always keeping an open mind. If the evidence changes, I'll change my mind. The problem with interstellar objects is we have how many total in our database? 3 in the
three,
last couple of years. So when someone says, "Well, this is a really unusual object," compared to what? I mean, how deep is our database? So this is what's often called the low information zone, like in the study of UAPs and UFOs. You can't quite make it out. We're not quite sure what it is we're looking at. The object is blurry. The videos are grainy. And so there, our imagination fills in the blanks, and we can speculate all we want, which is fine. That's all part of science, as Avi says. So okay, that's good. But what do we actually know about these kinds of objects? I'm not a planetary scientist, but my podcast guest yesterday, Alan Stern, is. He's one of the world's leading planetary scientists. He was head of the New Horizons spacecraft that went to Pluto. I had him on my podcast for other reasons. He's worried about the current Congress shutting down New Horizons, along with 54 other space missions that are currently underway for budgetary reasons. So I took the opportunity to ask him about this. He's well aware of 3i Atlas. He's been following it. He knows you, Avi. He's a big fan. He loves you. So I'm going to read his opinion. So it has nothing to do with you personally. He likes you. He thinks the Galileo project is great. He thinks what you're doing to promote science is super. I read him the little blurb from your email about the NASCAR guy wants to put your mug on the hood of his car.
And Michael, you are a member of the Galileo project, correct?
I am. Yes, absolutely. Yeah, support it. Absolutely.
Yeah.
And, all that would be good for science. Anyway, here's, so I teed it up for him, but as you did, Brian,
Yeah.
and here's what he says. I beg to differ. I know a fair amount about this. I'm not now one of the world's leading experts, but I used to be. I've published scientific papers that were peer reviewed about this phenomenon. And the way it works is this. He says, bear with me for a moment to give you some background. So we'll do that for your general listeners, Brian. Almost every star that we look at we see planets have formed, or they're forming now if it's a young star. So planets are ubiquitous. And when planetary systems form and you get to real big objects, the ones we call planets, their gravitational muscle clears out the regions between the orbits of the planets, and it just starts flinging stuff out. Now, that's not a technical term, but in effect, that's what happens. And just like the Voyager spacecraft intentionally would get flung, or like my New Horizons spacecraft that me and 2,500 of my best friends built and flew to Pluto, got flung by the planet Jupiter to get to Pluto faster. All of these inanimate objects get thrown all around the solar system, and many of them get thrown out of the solar system altogether into interstellar space. And so for a long time, ever since the 1960s and 70s, scientific papers were predicting that there was an uncountable number of these interstellar comets, and that as our solar system moves through space, they're passing by, sort of like in the fall when you see a cottonwood tree, just seeds going by in the wind. And we've recently, in the last less than 10 years, developed the capability to find these needles in the haystack. 3i Atlas is one of them. Now, 3i Atlas is the third one we found, and we're probably going to find a lot more now that we know how to do it, which is great because these are samples from other solar systems, so they're scientifically valuable. But 3i Atlas has not gotten close to any planets. It's going past the orbits of planets, but it's not even within millions of miles. It's within tens of millions or hundreds of millions of miles. So when you hear it's passing by Mars, it's passing by Mars at a great distance. It's passing by Jupiter at a great distance. It's just flying through our solar system as an inanimate object that's close enough for us to study. And we're going to learn a lot from it, but it's not like a Voyager spacecraft that's been targeted to fly by for close reconnaissance observations. So when you read in the press about it, and the language is sometimes not as precise as the scientists would use it, but I'm telling you, when you read that it's passing by all these different planets, it's very far from them. For example, the closest it will get to Mars is 29 million kilometers, or roughly 20 million miles. That's 100 times as far as from Mars as the moon is from Earth. It's crazy far away. So then I asked him about the outgassing. Does it look like a comet, or is that changing now? What's your opinion? As far as it goes, it looks like a comet, a big comet. Because, and by the way, the reason it's big is because the only ones we can detect are the big ones.
That's not
Later,
true.
when our capabilities are better, we'll detect smaller ones. But it has
That's
a lot of these same gases, and we see come out of comets in our solar system, and some of the properties look a lot like a comet. But as we study more and more of these, hopefully we'll learn about the variety that different solar systems make in throwing these objects out into interstellar space, just like our solar system did long ago. And so it's a new area of astronomy because we didn't have this capability until 2017 or so. So I then say, so it's something like a probability issue. And he says, right, there's something like 100 billion stars in the Milky Way. And if solar systems are common, as we think they are from the data, then every solar system has ejected somewhere between 1 billion and 1 trillion of these interstellar objects. So the galaxy is populated with something like 1 billion times 100 billion to 1 trillion times 100 billion of these things. They're everywhere. And then I say, oh
okay.
my God. I say, oh my God. And he says, yeah. And of course, space is enormously big. That's why we call it space. And they're very spread out from one another. But still, the
Okay.
numbers are, not to make a pun, they're astronomical. Okay.
Michael,
Astronomical.
So yeah,
Michael,
Avi, how do you respond?
yeah, this is poetry what you're reading, and I just wanted to explain that obviously this is what we expect. What he's describing is what we expect. What I was describing is what we see. And if we see an object that is tens of kilometers large, 1 million times more massive than the previous interstellar object, it's not a selection effect. We saw 100-meter objects, like ʻOumuamua and Borisov before. Now we are talking about an object that is hundreds of times bigger. Okay, so where are the objects in between? And the point is, it's not the poetry where you say, oh, there are plenty of them. No, we should have seen 1 million objects the size of ʻOumuamua or Borisov before we see one giant rock like that. And I wrote a paper as soon as it was discovered. It's all about the details. I wrote a paper showing that you really cannot, it's untenable to account for the delivery of an object that is tens of kilometers in diameter once per decade to the inner solar system by orders of magnitude, by a factor of at least 10,000. So you fall short of the mass reservoir of rocky material in interstellar space. You just can't deliver such a giant rock once per decade. You can do it once per tens of thousands of years if you package all the rocky material into 20-kilometer rocks. Okay, so that's one aspect. The second is whether it's passing close to planets or not. Well, I'm talking about the fact that the orbital plane, the trajectory of this object is aligned with the orbital plane of the planets to within 5 degrees, and the chance of that is 1 in 500. These are all numbers.
What was the or inclination of ʻOumuamua? I've forgotten. You
Oh, it
mentioned
was huge. We are talking about things of the 40, 60 degrees. I don't even remember that.
Just
because
to
it was
explain
not.
for the audience, the reason that this is sort of uniquely or suspicious in some way, Avi, is because you'd expect if they're truly random, they come from anywhere. That means that their
Yes.
inclination if you think about the solar system as a disk, just for the audience, you think about it as a disk, that disk is relatively narrow if you project it in space, right? So space
Right.
is all 360 degrees in one axis of rotation, or 180. That's a very large phase space to occupy, and the probability of an object entering in within a narrow acceptance angle,
Right.
is what you're saying, is therefore suspiciously low, or is low.
Yeah.
Now,
So
there's many ways
it's
that you
all
could
about
get.
numbers. You see, it's all about numbers. All I'm
Yeah.
talking about is about specific details on this object. And of course, if it was coming at a random angle, if it was the size, of order 1 kilometer or less, the way the other objects were, I would never mention that as anomaly. That would never. Now, of course, what Stern is saying is entirely correct, and that's what we would expect. But we don't see it. It's not what we see. We see evidence for a giant object. Now, one may say, okay, maybe it's a cloud of dust, but then we don't see a cometary tail behind it. So, you know,
Could we
you
have
need to
missed, though,
accept.
as Michael pointed out, could we have not missed many smaller objects because of
No,
A, the technology
no,
wasn't sophisticated?
because no, because the point is that to detect an object by reflection of sunlight, you just need to be bigger than 100 meters. Okay, we know the sensitivity of our telescopes, the Pan-STARRS, or in this case the Atlas telescope, or now we have the Rubin Observatory. So we can see objects that are of order the size of a football field or bigger. But this one is hundreds of times bigger if it is a solid
Sure,
object. So that's
sure.
that's my puzzle, because
Mhm.
the mass scales like size cubed. And if you increase the size by a factor of 100, you need a mass that is a million times bigger. And usually, objects that are a million times more massive are a million times rarer, because you just don't have the material to make them.
And now, Michael, you are very, closely related in my mind to kind of the living embodiment of this man, Carl Sagan. He's got a longer neck than you do, my finger puppet here. Carl Sagan's very famous for saying such things as extraordinary claims require extraordinary evidence. Avi and I are practicing scientists. And I've never reached into a drawer that, I've got my evidence over here, Michael, and then now, but I'm going to pull out the evidence is evidence in the Bayesian framework. So when Avi is mounting this very logical case, what's going through your mind? When does it reach the standard of Saganism of being extraordinary? And what does that even mean?
Well, again, we have an N of 3, so it's hard to know how representative any of these objects are.
Right.
So when Avi says, well, this one's 100 times larger than the other two, okay, but maybe we got Kareem Abdul-Jabbar out of the out of the random sample of humans. It's just with
No, but
3.
the thing is that Karim is a rare person, right, in terms of his height.
Yes,
And
that's what I'm saying. I mean, by chance, any of this same thing with the orbital trajectory. By the way, I asked Alan Stern about this. All right, so let's say this is our here. I'll just use my guest book here, the plane of the ecliptic. So objects could come in from here, from this angle, from this angle. So we have 3, an N of 3. 2 of them came from just random angles, and so did the third one. But Avi's saying, oh, but it came in at this angle. More along the plane of the ecliptic, which is the kind of thing a planetary scientist working for NASA would do to program the spacecraft to hit as many planets as possible. Again, with an N of 3, I just
yeah,
how can we really
but
say?
what about nickel without iron? That's
Oh, before we
another.
get there, hold on, Avi, hold on. I want to ask you, Avi, we were having this podcast in 2013, okay, if podcast even existed, who knows, back then, if podcast even existed. No, Michael's show certainly did. If we were having this
No,
conversation and I said, well,
a long time ago.
you've been doing this a long time. If I said to you, Avi, professor, please tell me, what are the odds that we're going to see 3 objects? Let me just say, even the one object that even you agree is a comet, right? Borisov is a comet. That was interstellar number 2, right? So let's say,
Right.
what is the odd that it's going to have these exact properties, sort of the look elsewhere effect? What would you have told me back then? Like, we're never going to
Zero.
see it. We're always going to see
Very,
it.
very small probability. And I don't like science fiction. If I never read the Rendezvous with Rama, and in retrospect, Arthur C. Clarke did talk about a technological object that is roughly those dimensions of tens of kilometers. Okay, and I would completely dismiss it. Back in 2013, I would think it's unreasonable. Now, let me explain another thing. Why am I advocating for that? It's because the mainstream is not reasonable. Okay, so for example, when Sphere X realized from the flux that it could be 46 kilometers in diameter, they immediately write in the next sentence, and they see it as a problem. They immediately write in the next sentence, well, it must mean that 99% of the flux that we see is being scattered by dust around the object. But then they don't ask the next question of why don't we see a cometary tail? So there is this tendency of mainstream scientists to hide anomalies under the carpet of traditional thinking. And that is one of the main reasons I'm trying to bring it to light. Just also to demonstrate that it's not as if things are done in a fair way, in an open-minded way. We didn't go very far from the days of, Galileo Galilei. There is still a lot of resentment to anything that doesn't agree with what we think it should be.
Mm.
And you might argue science is supposed to be based on evidence. Yes, but scientists know very well that when the evidence doesn't conform, they can hide it, they can sort of smear it, they can call it a dark comet, even if you don't see a cometary tail, meaning that the emperor has clothes, but the clothes are not visible. That's what the story of Hans Christian Andersen was about. And scientists are very good at that. And that's why there are very few discoveries per decade now compared to 100 years ago. I was at the Niels Bohr Institute just last week. And I was amazed because I went to the auditorium and I saw the place that I remember from a photograph that was taken in 1930 with Niels Bohr sitting next to Werner Heisenberg, sitting near Lev Landau, all the pioneers of quantum mechanics. And I sat on the bench, and they said it was a wooden bench, and they said, "Oh, you're sitting where Wolfgang Pauli sat in that conference in the middle." And all I can think of is that it's not very comfortable. This bench is not comfortable, and they must have had very much worse quality of life back then. But I would trade everything I have to go back 95 years and be there, just because the spirit of the conversation was very open-minded.
Yeah, let me
nobody was ridiculed for imagining
exactly.
something like
So
quantum
I
mechanics.
don't know about that.
well, let
Avi.
me play this for you guys, and audience
Oh,
has
yeah.
to tell me if they can hear it, because this is exactly what Avi I think is referring to, and I want to get Michael's response to it. The public square, the bench that you're talking about nowadays is played the role is being played by the Joe Rogan Experience. Now, all of us have been on the show, but yesterday, in fact, I believe there was this gentleman talking with Joe, and you'll kind of note a little bit of the dismissive attitude that Joe takes. So I don't know if you guys can hear it out there. So audience, you need to give a thumbs up if you can hear it, or a thumbs down if you can't hear it. I'm going to play it now.
I can't hear it.
Can you guys hear it out there? Please put a thumbs up if you can hear it. Thumbs up or thumbs down if you can hear it, or type in the comments if you can hear that, please. Did you hear the Australian accent playing?
I don't hear anything.
You guys won't hear it, but I think the audience will.
I see. Okay.
All right, so here he's going to continue talking to Joe. I don't think we can hear it out there. Okay, so the folks are saying they can't hear it. Unfortunately, can't hear it. Let me try
who is
one.
the guest? I'm looking at the list of Rogan's latest guests.
Yeah,
Who was
let
it?
me.
Was
Here we
it
go.
Ben Van Kerwick?
We're going to find out, like this three-eye atlas
Here we go.
thing.
Yeah, what is that
I think we
thing?
can hear it.
Well, Avi Loeb is convinced that it's a UFO, but that's what he does.
Yeah,
right?
that's
He did with that other one, ʻOumuamua or
ʻOumuamua.
So that one was a little odd.
That was weird. So it wasn't the weirdest thing about ʻOumuamua seems to be its path when after it turned around the sun and accelerated. Like that was the standard model of physics said it shouldn't have done that, and it seems to have exhibited sort of motion that was not what we predicted it would do. That's as much as we can.
Acceleration.
It accelerated. It was.
Okay, so you get the point here. Did you guys? I don't know if you guys heard it, but Joe's expressing skepticism. And
who is that? Do you know who
I'll look it up. I'm sorry, I don't want to get
the guy Ben Van Kerwick, who was on yesterday. Who's an independent researcher exploring ancient mysteries. Anyway, I mean, I'll just comment on that. I mean, Joe's exaggerating what he thinks Avi is saying. Avi has not said, "I absolutely believe it's an alien spacecraft." He hasn't said that. But to the point, Brian, of how the public perceives these things, Joe is reflecting how most people, when they listen or read Avi, they don't nuance when he cautions and has qualifications about his statements. They just hear him saying, "I think it's aliens." And so if I make a slightly larger point, Avi, I mean, the reason TV crews and media are pounding at your door every day and they want to put your face on a NASCAR race car, and they're not doing that for Alan Stern, is because he's just saying, I don't know what it is. It's probably just a typical comet or of some kind of, and you're saying more than that. You're saying, yeah, it probably is that, but it could be an alien spaceship. And the brains of the general public just auto corrects to, Avi says it's an alien. Well, he didn't say that.
It's not the brains of the public. It's more the reporters that want clickbait.
Well,
and what I would like to argue is that science can be exciting if you allow yourself to explore possibilities. If you know in advance what it's all about, that it's a rock and there are plenty of them, and you start talking as if you're a poet, that distances are vast, times are long, and who cares? Let's look at the details of this object. Are they anomalous or not? That's pretty much what we are discussing here as,
I mean,
as
Avi, if you
scientists.
said, look, I think I've found a new kind of comet that is doesn't exist in our solar system, but this new comet exists in this
Oh
other
yeah,
solar system.
that's what was
No,
said about Oumuamua,
people
by the
would not
way.
be. You would not have anything close to the interest in your articles and what you have to say.
Yeah, but
compared to now.
here is my point, Michael, and I think you would agree with that. Right now, the mainstream of the astronomy community puts its highest priority, in astrobiology, in the search for microbes on other exoplanets, the molecular fingerprints. And the situation is similar to you living in a house, okay, and you know that microbes exist in the house long before you came there, and they still are there. And then you just look at other houses on the street, which are, Earth Sun's analogs that we see in the Milky Way galaxy. So, we know that there should be of order billions of them. Okay, and we see those houses on the cosmic streets. But then, my colleagues, the mainstream astrobiologists, say, imagining that these houses have residents is really extraordinary, and we should not contemplate that. Let's just imagine that they have microbes in them. Now, the problem of that is that you really need to build a huge telescope to look through the window of your home and figure out if there are microbes in the other houses on the street. That's really difficult. And that's what they want to do. They want to put more than $10 billion in the search for the molecular fingerprints in the atmospheres of 25 exoplanets within the Habitable World Observatory. What I'm saying is, let's hedge our bets, because if there is a resident in one of those houses, the resident might knock on our door, we might find a tennis ball in our backyard, or we will see some construction project happening at the yard far away. That would be much easier to detect. So what I'm saying, let's bring some sense, common sense, into academia and split and hedge the bets and split the funding. Put a few $1 billion towards searching for microbes. I have no issue that we should do that, because they must be very common. But also put billions of dollars towards the search for intelligence. And what I hear back is zero federal funding to the search for intelligence. More than $10 billion over 2 decades to the search for microbes.
Now, Michael,
That's
what would you do?
The imbalance that I'm funding.
Michael, let's say you're in charge of NASA. You get appointed through some uncanny means, but you're head of NASA now. At what threshold of Bayesian confidence, you keep mentioning, rightfully so, when do you start to devote serious attention, which means money and people's careers and time, to guarding or investigating it, as if the assumption, maybe low probability or not, it actually is technological in origin and possibly malevolent?
Well, I don't think it would be.
I mean, again, I'm saying there's always a probability, right?
I would say the probability of finding an extraterrestrial spacecraft of some kind, or a signal from SETI or whatever, is extremely low, probably less than 1%. But if I was the economic czar and I could hand out money and I had $10 billion to hand out, I'd give Avi or whoever $1 billion of the 10 billion, because I think the import of the discovery is so massive, so important, so huge, so interesting in terms of our place in the cosmos. And, it's one of the oldest questions of all time in all of history, science is there somebody else out there? Are we alone? And so I think it's worth the money. I support the SETI program. It's unfortunate that, that their budget got cut back in I think it was the early 90s.
1993.
Yeah. So I mean, that's
Michael, you're repeating Pascal's wager, which basically he argued that we should discuss God, because the implications would be.
Well, I think if there are aliens, they are gods to us. I think that if there is a God, it's going to be a extraordinarily advanced extraterrestrial intelligence.
Let's stick with evidence, because Avi did mention, some very unusual properties, such as the presence of nickel without iron, unlike the meteorites you get when you go to briankeating.com, potentially winning one of these. And you're guaranteed to win if you have a .edu email address and live in the United States. I've sent that, like I said, thousands of these. And you'll get a bountiful amount of knowledge when you investigate this extraterrestrial object called my next book, Focus Like a Nobel Prize Winner, comes out on Tuesday. You can get the Kindle edition for 1 week only 99 cents. Come on. Can't beat that deal in this or any other multiverse. Now, Michael, if we were to see some objects that are some aspects of this object, what would be sort of the most convincing to you as a skeptic? I mean, that's literally your brand. If you were a skeptic, what would it be? Would it be something like this? Or I actually have the original monolith from 2001. We heard about Rendezvous with Rama. Here it
Well, that
comes.
would do it.
Here's the monolith. Here's one of these things. What level of,
Yeah.
of so-called proof? I mean, we can't prove it, right? In any case, but what level of confidence interval would be established? Is the presence of, for example, nickel without iron, as Avi has already mentioned, is that, piquing the curiosity and increasing the Bayesian confidence?
That one I forgot to ask Alan Sturt about, and I don't know anything about that. So,
well, maybe Avi can explain it. Well, Avi, why is that significant? And then why should Michael be, interested in this? And why should I be interested?
Yeah, so the Very Large Telescope detected the significant amount of nickel, but put only an upper limit, a quite large upper limit on the ratio of nickel to iron. So in other words, there is no detection of iron, and that is very different from other comets where you see both of them together, because these two elements, nickel and iron, are produced in supernova explosions, exploding stars. And in fact, iron in the solar abundance of elements has a higher fraction. And nevertheless, in this case, we see only nickel. And so one suggestion that was made by the authors of that paper was to say maybe there was a production of a preferred production of nickel through a carbonyl pathway. The carbonyl pathway is known from the industry. That's the path by which we produce nickel alloys. And nickel alloys without iron are very useful as the skin of spacecraft, for example. And so they mentioned in the paper that maybe nature follows the path that we are using industrially. We haven't seen that in other comets. I looked at the distribution, and in all of them, the iron to nickel ratio is of order unity, with some variations, but definitely not as extreme as in this particular case. So that's just another anomaly. I don't make a lot of it, but I'm just saying there are anomalies of this object. And I asked myself, will I be happy if it ends up being a rock? And of course I will be happy, because there is less risk for humanity, no threat. But on the other hand, I think humanity desperately needs a wake-up call. If you just read the news every day, our priorities are really do not testify that we are intelligent. We invest most of our resources in conflicts. That's what we tend to do. And instead of coming together and towards a more prosperous future for all of us, and perhaps just finding a threat in the sky would bring us together, because we would realize we're all in the same boat. That's one reason I think that will be good news if it ends up being technological.
Well, that was Reagan's argument.
So how do we guard against, Michael, reading too much into maybe esoteric, things like chemical line abundances or instrumental artifacts and systematic? How do you guard against that, but also maintain, you have to be optimistic. It's too depressing to be a scientist without some of the optimism. Now, we're not all blessed to have the supernova-like optimism of our good friend Avi, but how do you guard against, kind of over-exuberance or over-pessimism? You know very well, you're always, accused of being a wet blanket, right? So how do you guard against those two, Scylla and Charybdis?
Right, and I'll try to answer the previous question that you asked as well, that what would it take for me to be convinced? Well, I'm not a planetary scientist, so I would defer to what the consensus is among the scientists that know about this. People like Alan Stern, who does not have a grudge against Avi. He's not dogmatically closed-minded. And by the way, Avi, I think I would disagree with some of your history of science there. I mean, Einstein was harshly criticized at first. It was a long time before he became his ideas became accepted, and then he became rather dogmatically closed-minded about quantum physics, for example, when he became the authority. I don't think there's anything different now about like the rate of discoveries and things like that. I mean, you've cited some journal editors who say you can't mention that 3I Atlas could be technological. Well, that's not good, but I don't think that's typical. I think most scientists are relatively open-minded, but they're conservative in the sense that most extraordinary claims turn out not to be true. And most ideas that scientists are spitballing in their labs turn out not to be true. And this is just very common. And so it's
By the way,
unusual to be
it's
right.
very common. It's very common also in the mainstream. As I mentioned, the suggestion for dark matter, like the lightest supersymmetric particle, that turned out to be wrong. And when I entered astrophysics, that was the dominant popular view, and people got awards, prizes, honors for just suggesting that, and they were sure that it must be true. And then the Large Hadron Collider didn't find it. So what I'm saying is, it's we cannot necessarily trust the mainstream, those people who you call experts.
Not alone, but without it, what have we got? I mean, we have.
Without it, we have our imagination, Michael.
I know, but you have all the alternative physics guys that write you and me and everybody, and Brian and everybody else with their theories of everything that they've worked out in their garage on the weekends, and there's just nothing to them. Most of them have no contributions to make. So working scientists that are busy simply don't have the time to entertain every single hypothesis.
No, that's not. I would disagree with that. I would say that there are gatekeepers that are maintaining the herd in a very tight configuration along one path. Wait a second, along one path, and very often this path leads nowhere. And if we were to explore multiple paths, I'm not saying infinite number of paths or any person who has an idea, we should explore it. But I'm just saying, let's allow more diversity of and nourish that diversity of opinions, because we may not know in advance which path leads us to a discovery. And I think that would improve the efficiency of science if we allow that. You see that also in corporations, right? Because if you allow people to brainstorm and most of the ideas turn out to be wrong, it turns out to be very financially viable for corporations to do that, because one good idea pays for everything else.
You mentioned the word gatekeeper, and Michael, I have a gate around my pool here. I think it's a law in California. We have a gate around the country. It's called the border. A lot of the people that support, the stuff that Avi's doing or President Trump do are extremely supportive of gates in certain circumstances. Do you view gatekeeper as a pejorative when people accuse you of that?
No, but Avi's a gatekeeper. He's at Harvard. Come on. He's in the mainstream. So Avi, you're in a position to do something about the gate being not porous enough. It's too tight. Okay, then loosen it up a little bit. Fine.
Okay, that's what I'm trying to do.
Now let's talk about So let's talk about, what does the public have as a right? Or for example, I'm often hear things like, it's our data, we paid for it, et cetera, et cetera. To the extent that the average person could do data analysis, Avi, what can we really expect as professional scientists? What do we have an obligation to provide to the public so they can do their own research, as it said, and not be accused of being a gatekeeper?
So here is my take. Currently, the practice is the scientists find out the answer, they decide about the press conference, and they tell the public what the public should know. Okay, and that feels like being in a lecture room where the lecturer tells the students what they need to know. And there is a hierarchy here. You don't allow the public to feed back into the process. There is no oversight. And the problem with that approach is that, first of all, there are lots of taxpayers' funds which are spent on things the public doesn't care about. Okay, and I include extra dimension string theory in that for decades. Okay, and just because there is no oversight, because the same scientists are sitting on committees that are providing the funding and deciding in their echo chamber that it's worthwhile doing without any feedback from an outside world. Okay, and that's a problem. But the second thing is, I think it's inappropriate to communicate to the public what they should know, but rather also listen to the public. If the public cares about a subject and the public pays taxes to support science, science should attend to that subject. Okay, if, for example, the public wants to know if there is intelligence out there, you can't just say, I zero out federal funding to this subject while I'm paying tens of billions of dollars towards the search for microbes. Why? Because the public wants to know the answer to the other question. And so how can you ignore it? And That alienates the public and creates this sense of hierarchy. And
Right,
that
but
the
a
scientists
counter argument, just to push back with love and respect, as I often do, if you ask the public, that the top podcasts that are above me and Michael, half of them are about UAPs, fine. The other half are about Sasquatch. So, there's an awful lot of interest in the public in things that have nothing to do with either one. If you cancel microbes, just like when they canceled the superconducting super collider, as you know, it didn't go into condensed matter physics or astrophysics. It went away. That budget went away. And so, Michael, and I do want to compliment both of you guys, because you guys do an exceptional job of science communication, and you're not paid to do it. NASA doesn't pay you, Michael. NASA doesn't pay Avi to do what he's doing. You guys are the epitome of what scientists should be, because Avi's right. Our employer at some level is the taxpayer. But that doesn't mean we always have to do what the taxpayer, demands of us to do. Even I, as a humble state employee of the state of California. And I do want to make a note that we will take audience questions, because I often love to take questions from the audience. You have to be a channel subscriber in order to ask questions, but we'll do that down below in just a little bit. Okay, Michael, what would it take for you to falsify the null hypothesis in your case that this is not? And then I'm going to ask Avi, how could you falsify your, positive hypothesis that it is alien technology? Michael, you first. What would it take to kind of convince you? What would it take? A combination of would it be purely scientific, or would we bring in other types of epistemological searching? What would it take to convince you?
I guess if the consensus among planetary scientists that study these things was that this is of technological origin, then yeah. How should I know? Again, but let me make a broader point. How do any of us fact check anything we read in the public? You hear RFKJ say vaccines are extremely dangerous and they've not been tested. How would I know if he's right or not? I have to go to the experts who study this stuff. Now, sometimes they get it wrong. Sometimes they exaggerate and so on, as we saw during COVID. And the public trust in the CDC, for example, and Anthony Fauci and Francis Collins, plummeted because of that. So we have to be careful. But without that, then you have nothing but RFKJ type vaccine skeptics in that particular field. So there has to be some way that the average person can check these things. 99% of knowledge that's out there, I have no idea personally if it's true or not. Was the 2020 election rigged? How the hell should I know? I depend on the Justice Department and the people that run these things to tell me if it was or not. So that would be the case here. If someone like an Alan Stern said, I think this new photograph we got and data from the Mars camera, shows it probably is technological. Like, okay. I don't have a dog in the fight. I'd be glad for it to be technological.
Okay, and so Avi, let me ask you the same question. So I'm reading from our friend David Kipping, who put out a respectful but very contrary video to kind of dispute some of the claims with respect. He also was on Rogan doing the same thing. So he points out all these different factoids: the interstellar asteroid abundance. He argues we don't know it fully yet. The velocity and the local standard of rest, we'll get into that later. He's talking about the different, reasons why, for example, ʻOumuamua, he says that was moving slowly. Now you're saying that this object is moving quickly. The unusual orbit is an observational selection effect, et cetera, et cetera. And then lastly, he gets into the technology of the solar sail. How do you refute that? And what would it take for you to say him and other people who are experts in this field? He's not a planetary scientist. I don't think you need specific planetary scientists, but astrophysicists in general. He's very well known and respected. So what would it take for you to refute your null hypothesis?
Right. So first, I should say, the truth is not decided by authority. I don't care about what Alan Stern says. I don't care about what David Kipping says. If the data shows something really anomalous, they can continue to say that it's a dark comet. On January 2nd, 2025, there was an object cataloged by the Minor Planet Center, the main authority designated by the International Astronomy Union. They found a near-Earth asteroid and gave it a name. And then they realized a day later, that one follows the path of the Tesla Roadster car that was launched by SpaceX in 2018. Removed it immediately from their catalog. And there were dozens of cases like that, where astronomers say it's a rock. Oh, wait a minute. No, it's a spacecraft or some space debris that we launched. Now, what about spacecraft or space debris that other civilizations launched? We don't know their trajectories. And those same astronomers that Michael calls experts would say and insist that they must be rocks of a type that we've never seen before. That was done for Oumuamua. There were experts that Michael would really respect that said, it's a hydrogen iceberg, it's a nitrogen iceberg, it's a dust bunny. These were the mainstream suggestions. Can you believe it? Things we've never seen before. A dust bunny being Oumuamua, a hydrogen iceberg. These are the experts that Michael wants us to listen to. And I'm saying science depends on the level of evidence. So obviously, eventually, if we have enough evidence. So what I would like, if I saw that 3i Atlas was maneuvering, just to give an example, if it was maneuvering, then obviously, the stock market may crash, because that kind of a maneuver that cannot be accounted for by the rocket effect of a comet, if it's like zigzagging or approaching Earth or doing or releasing some mini probes, that would be clear indication that it's technological. Or if it has it broadcasts something or has artificial lights. However, if it becomes clear that it has a cometary tail of the type that is expected from natural objects, I invented a scale last month, calling it, now it's called the Loeb scale, where 0 means natural, 10 means artificial and likely to threaten Earth. So far I gave it a 4, 3i Atlas, but I would bring it down to 0 if we get more data as it comes close to the sun and it erupts just like a comet. I would say, yeah, it's natural. I bring it down to 0. Now you may ask, how is it that you are changing your mind? Is it under pressure? No, it's because we have more data. And science, whoever pretends that scientists know the answer is wrong, because we thought that we detected B-mode polarization from inflation. It ended up being dust from the Milky Way galaxy, and that's just an example of how science is done in iterations. It takes more and more data eventually to figure out what's going on.
And that was the subject of my first book, which reminds me to make sure people know about my fourth book, which is now out, coming for 99 cents only to your Kindle on Tuesday. Focus Like a Nobel Prize winner. Click the link down below. Michael, what would you do to avoid this sort of impasse that we seem to have? We have to listen to experts, but then some experts we shouldn't listen to. So how does a layperson, again, a lot of the audience, most of the audiences are lay people. So how do they know who to listen to? Should it be people like Keating? Should it be Avi? What do we do?
Well, Avi is one of the experts that we should listen to. He's not an outsider. He's not a fringe thinker. He's at Harvard, for God's sakes. I mean, it doesn't get more mainstream than that. So, but I mean, Avi, are your children vaccinated? And if so, why did you vaccinate them? Did you do your own research? Did you rely on experts who know something about this, like your own personal doctor, your pediatrician that takes care of your kids? I mean, this is nonsense that we shouldn't listen to the experts and do our own research. That's just bullshit. I mean, this is the death of expertise. This is a problem that we're facing in all areas.
I guess what Brian is asking you, Michael, is how do you know if the experts are not just fooling you?
Because there's a community of scientific experts. Don't listen to any one of them, but there's a point. If all peer review is completely broken, then what's the point of having any standards of evidence at all? I mean, everything you're talking about, Avi, is based on evidence. Okay, well, you don't think we should just throw out all the evidence and just people?
No, I don't think we should throw it away, but I also know for a fact that a lot of the review process is highly sensitive to subjective
I know, but what's the alternative? What are you proposing?
What I'm proposing is a different system where innovation takes center stage. Right now, the practice is that risk taking is avoided by most scientists because they're worried about what people like Keating will argue against them if they were to say something different, or what there is a lot of pushback. Now, the main harm that is done by people criticizing me is in discouraging young people to think differently, because the young people see it and they worry about their job prospects. And I think the culture right now in academia and science is not sufficiently innovative, and we can correct that.
Now, Michael, why did you join?
Oh, sorry.
Sorry,
I mean,
Michael. So
one way you can correct it, Avi, is through all those billionaires you've been meeting that want to courtesy your your favor there. Get some of them to get the checkbook out and
I agree.
well, he has, and I
private
want to.
funding of science has
I
a
agree.
long
I
tradition.
just, last week I hired 3 new postdocs in the Galileo project. I'm trying to do my best, but
see,
the problem,
you're a gatekeeper, and you've opened the gate. That's a good thing.
yes.
Now, Michael, why did you join the Galileo project aside from the
Because I
fact
think
that
I agree with everything Avi's saying here about the need for, well, first of all, it's, of course, the greatest subject of all is there, somebody else out there somewhere, and have they come here?
cosmology? Come on, give us some
Yeah,
cosmology.
that's it. And so, Avi wants to actually look with better cameras. It's the UAP thing. Again, that low information zone where, why are they always grainy videos and blurry photographs when there's, a couple billion high resolution phones walking around Earth? Okay, well, let's do something about it. And then, of course, I'm a fan of Galileo.
Now,
Historian of
Michael, you
science.
might be also the
good.
only person. I don't think that the entire audience is familiar with your encounters with extraterrestrials. Do you want to explain
Oh,
your
you mean my alien abduction?
your abduction? Yeah, no. In all
Well,
seriousness, let's go through it because I think it'll be instructive for my audience members that may not know your backstory.
oh gosh. Okay, yeah, I've written about that quite a bit. Yeah, so I was abducted by aliens in August of 1983 on the side of the road in Nebraska, outside of Hagler, Nebraska. It was a large a ship, a large craft with bright lights, and the aliens got out. And now, interestingly, they looked exactly human. In fact, they looked a lot like people I know. So the context of this is the 3,000-mile nonstop transcontinental bicycle race across America that I was competing in 1983. And I'd ridden nonstop from the Santa Monica Pier all the way to Nebraska. It's about 1,280 miles with zero sleep and almost no stops. And so I'm just hallucinating. I was just simply, and what I was hallucinating was reflecting a deep memory I had from childhood of a TV show called The Invaders, starring Roy Thinnis on CBS, in which this was a body snatching motif, in which aliens had come to Earth and were basically snatching the bodies. Just body snatching, it's called, where the aliens look exactly like your neighbors. And so but for the plot line, they had to have some way for people to tell. And so it was a stiff little finger that for some reason they could traverse the vast distances of interstellar space, and replicate a human and DNA and all that, but they couldn't bend the tendons in their little finger. Anyway, it was just a plot device. But all that happened to me on the side of the road. It was just my support crew. I'd been hallucinating, and I slept for 90 minutes and got back up. And you can actually watch this if you go to YouTube and type in Michael Shermer, alien abduction. You'll see me explaining to Eric Hayden and the ABC Wild World of Sports camera crew exactly what happened, because he goes, "How's it going?" I said, "Not so good. I was abducted by aliens." He's like, "What?" So I told him the whole story. So it actually happened all in my head, of course.
By the way, I should comment, Brian, that when I agreed that to bring Michael to the Galileo project, I told Michael that if we do find evidence, my hope is that Michael will change the name of his magazine from Skeptic to Believer.
Believer, yes. Actually, Avi, since that time, there is a magazine called Believer. So how about just Believe?
Okay, so I do want to take some questions from the audience in just a few minutes. You'll have to be a subscriber to ask questions. I got to pander in some way or another. But before we go there, you mentioned a little bit ago, and there is some rumbling in the chat, whether or not Michael is coming at this from a religious perspective. And I wonder, Michael, if you could talk about what you mentioned before, that if they are real, then they would sort of be like our gods. And obviously there's a lot of eschatological and other kind of overlays always with the alien topic. Why do you think that is? I mean, we don't have that in like cosmology necessarily. I mean, we have the Genesis 1:1, but I mean, besides that, we don't really talk about God. And if I'm doing condensed matter, nematic phase transitions and superconductors, I'm not gonna let me think about like if God oriented. Why is it so prevalent in topics like aliens, UAPs, UFOs?
Yeah, one of my early Scientific American columns was called Shermer's Last Law, because you shouldn't name laws after yourself.
Okay, Avi, you heard that, right?
Or
What about
scales.
scales? What about scales like the Loeb scale?
Anyway, it's I was just a riff off of Arthur C. Clarke's third law. Any sufficiently advanced extraterrestrial intelligence is indistinguishable from God. That is to say, if we do encounter aliens, they're not going to be just 5 years ahead of us or behind us. Well, they won't be behind us because we've just got achieved space travel, but they'd be, tens of thousands, hundreds of thousands, millions of years more advanced than us. And if you just take Moore's law, doubling of technological capabilities every 1 or 2 years, and you extrapolate that out 5,000, 10,000, 50,000, 100,000 million years, they'll be able to do things that to us would look like, omniscience and omnipotence. So anyway, that was my point of that little tongue in cheek. Sagan made this point that, it's not original to me, that the religious impulse to know that we're not alone, that there's somebody, some agent, something out there that knows we're here, and cares about us, or in some way is more moral than us, is deeply embedded in the human psyche, and it's probably the basis of most religious impulses related to those big questions: where we came from, why we're here, and so on. And so I think the search for extraterrestrial intelligence, in a way, is, I'm not saying it's a religious thing. It's driven by the same questions of, like, we all want to know. It's like roots writ large. Where did I come from? And I have to say, I mean, it is one of the greatest questions. I would love to know the answer. I would love to know that we're not alone. We just don't know. And so the point of
there is another aspect to it, that one reason I'm seeking a higher intelligence in interstellar space is because I don't often find it in academia. And
okay,
and so it's just like,
you are in academia. Come on.
Okay, yeah. But
That's
the
why
point
you can
is,
criticize.
Think about attending a party, and you just don't like the way the party goers are behaving, and you are looking through the window for an incoming guest that will improve the situation. So there is an opportunity for us to learn, of course, and one question is whether it will affect in any way the belief in God that religious people have. And I was asked this question by a group of scholars from Christianity Today, and I said that I have 2 daughters, and when the second one was born, it didn't take away from the love I have to the first one. So God, if you think of God as being able to attend only to one child, that is very demeaning. And if we have siblings, of course we will be jealous if they are more accomplished than we are, just like having a sibling that is more successful. But there is no conflict with the notion of the religious God.
Now, Avi and Michael, we're going to lose Michael in a few minutes, but Avi and I will continue in a little bit more technical level, talk about some of the technical details after Michael has to be abducted for his next appointment. Michael, we have a question, or a statement really, but I'm going to pose it to you, and that's that eyewitness testimony is nearly useless. What do you make about that? There's so many accounts from eminent pilots. I've had on Ryan Graves on my podcast. I've tried to talk to people like Lou Elizondo. He won't come on, but he keeps sending me stuff. But hopefully I'll get him on. But all these eyewitnesses, Michael, they can't surely all be making stuff up, can they?
Eyewitness testimony is not reliable. We know that from tons of studies. Let me read to you a quote from the astronaut and pilot Scott Kelly at a NASA press conference dealing with the latest flap of UAP sightings, in which the believers were saying, look, just this pilot saw it. And, they have, great credentials and great vision, and they know what they're seeing in space and in the atmosphere. Here's what Scott Kelly says. In my experience of flying over 15,000 hours in 30-something years in airplanes and in space, the environment that we fly in is very conducive to optical illusions. So I get why these pilots would look at that go fast video and think it's going really, really fast. I remember one time I was flying off Virginia Beach Military Operating Area, and my RIO, radar intercept officer, who sits in the back of the Tomcat, was convinced we flew by a UFO. I didn't see it, so we turned around to go look at it. Turns out it was a Bart Simpson balloon. My brother Scott Kelly, a former NASA astronaut and now also a U.S. Senator, shared a story with me about an experience he had years ago when he was the commander of the STS-124, the space shuttle. They were getting ready to close the payload bay doors of the space shuttle, and they see something in the payload bay, and they thought it was a tool, maybe a bolt. They couldn't quite figure it out, and they were potentially going to have to go do a spacewalk to retrieve it. But before they did that, my brother grabbed his camera and they took a picture of it. And when they blew up the picture, they realized this is not a bolt or a tool in the payload bay. It's the International Space Station 80 miles away.
Mm.
He says there are cases where pilots have rendezvoused on a buoy because they thought that was their wingman. It's just a very, very challenging environment to work, especially at night.
Yeah. And I can support that by mentioning an anecdote where I had someone send me an email, a photographer from of weddings, and he said, "I just have the best photo ever of a UFO that I captured during a wedding, and I want you to sign an NDA, a non-disclosure agreement." He asked me, I said, "I'm not signing any NDA. You want me to look at it? Just send it over." And so he agreed and sent it over, and I showed it to the Galileo project research team, and we realized that it was actually a napkin that was flying in the wind behind the groom. And I told it to him, and I assumed that he was disappointed.
Now, Michael, what about the fact that the U.S. government recently admitted that it was running basically what's called a psychological operation on members of the military? How does that, affect your credulity or not? First of all, why would they do that? And would they possibly do that because of the existence of the real, objects that they want to keep covered up? What do you make about this?
Yeah, the latter, right. I mean, did anybody know about the U-2 spy plane or the SR-71 Blackbird, when they were under development? I mean, the U-2 spy plane was developed in Burbank, right there in the middle of Los Angeles, and nobody knew about it, right? So governments can't keep secrets. Some secrets leak. Sometimes they cover up things that they're doing. We know that governments lie to their citizens. All governments, including democracies, do this. Our own government does this. We know that's from the history of the CIA and the FBI. They're not always forthcoming, to say the least. And so my interpretation of that is, sort of like with the Roswell incident. They initially said, it was initially they said, look, here's some debris. And it's a weather balloon. Well, it turns out it wasn't a weather balloon. It was Project Mogul, which was high altitude balloons with acoustic equipment to listen for nuclear explosions in the upper atmosphere that we were afraid the Soviets might be testing. And so, of course, they lied about that, because they're not going to say, hey, by the way, that debris you saw was from this secret Project Mogul that we're using so we can know what the Soviets are doing, because now the Soviets know we're doing it. So they lie for national security reasons, and so on. It could be something along those lines, and maybe there's some slight sense of humor about the whole thing. Look at what all these UFO nuts are talking about. Let's go ahead and float some of those ideas out there into the public and let them run with it so that we can keep doing what we're doing. That's entirely possible. It's not a very open, transparent approach to a democratic civil society, but that's the world we live in.
And speaking of that, Avi, you've first of all, I want to give you credit, because all these people, and some call them haters, and you've got like a whole bunch of people that troll you, both in our professional academy as well as, Michael, maybe you're not aware of this because you don't play the petty games that we professors play, but there's a lot of hatred that goes towards Avi. And I found it very interesting sociologically, because a few weeks ago, maybe a month ago, you got this on the radar of Congresswoman Luna of Florida, and she's since taken this mantle up. And at that time, it was to look at using the spacecraft Juno, what I know, it's the Jupiter observation, which is still in orbit and could do observations of this. First of all, I want to congratulate you for that. Second of all, I want to congratulate you for making your haters say, well, Avi's wrong about this being an object from interstellar technology, but he's got a good idea. But my idea is better. I'm going to use it to look for a plume from Vega, whatever. So that was an epic troll. I don't know if that was your intention, but why should what level does this government thing go up? Does it go all the way up to the president? I mean, what are they doing in Congress with our taxpayer money? And what could they be doing to maybe shed some light on this interesting object and other objects that are undoubtedly coming our way, right?
Yeah. So Congresswoman Luna did call me by phone and asked me for an update about 3i Atlas. I met her before at the briefing that I gave on May 1st, 2025 in the US Congress. And, I advocated for the scientific approach, where she doesn't need to listen to storytelling the way that Michael describes, because stories, can be fabricated, and science is really our best hope. The method of science is collecting evidence. You don't need to listen to people. Just collect as much data as possible, and you can tell the difference between, a genuine scientist and a conspiracy theorist. The way to tell the difference is give both of them a lot of data. The conspiracy theorist will be very worried about it because it may go against the narrative. The scientist, a genuine scientist, will be delighted because even if it changes the view that scientist had, we learn something new. So that is the process of scientific learning. Now, I'm not saying that practitioners of science, scientists, are all genuine scientists. Many of them are anti-science. They have a view, they have an echo chamber, and they want everything to conform to that. And so that's my problem with some of the scientists. But I should say, actually, that just last week there was a paper out saying we should look for technological signatures of interstellar objects. And I look at the author list, and in the author list, there are people who are attacking me personally on YouTube and on blogs. And I asked myself, how come? And then I remembered what Oscar Wilde said, that imitation is the sincerest form of flattery. Okay, so I don't mind as long as they say what I'm saying, that's fine. But what they're trying to do is basically say, if we happen to find technological signatures of an interstellar object, we want credit for that. This was discussed long ago. It's not about Avi. So they give me a hard time, but at the same time they want to diminish my prospects of getting recognized for saying that if it happens to be true.
Now,
And
Michael,
sorry?
sorry, Michael, just because you have to go in a couple of minutes, I want to ask you this. You stated very eloquently the challenges of eyewitness testimony, but let's talk about the title of this hearing, as I understand it, is the Whistleblower Protection Act. Now, why would we need whistleblower protection if these objects are not real or if they are representative of psychological operation? What do you make of this whistleblower?
Well, the idea there is you have insiders working in the government. These aren't just, the farmer Bob out in the field says he saw a light. These are people that presumably, working in government know something. So when you see like the Grush hearings and some of those congressional hearings where, they know somebody who knows somebody who worked in government that actually touched the spaceship, saw the aliens, studied them, and so on. And then you ask, well, who was that? Well, we can't tell you. Well, where was this? Can't tell you. Okay. So, and when you ask, well, why not? Well, it's classified, or, they're afraid of being punished. So, well, we have whistleblower laws, and that's what those are for, so that we can have transparency in government, these government agencies. So let's get it out there. Just release all the files, release the UFO files, the JFK files, the Epstein files, put them all out there. All right, gentlemen, I got to go. I'm going to just close with this final statement. Avi, you started off by saying scientists don't care about the Nobel Prize. They just want evidence. So if 3i Atlas turns out to be extraterrestrial intelligent technology and the Nobel Committee calls you at 5 a.m. and you're not already out on your early morning run, would you turn it down?
I will do the Bob Dylan act, because if we know that it's an intelligence, alien intelligence, it's much more worthwhile of my attention than a bunch of old people giving an award to another person.
Okay.
That I would do the Bob Dylan thing.
Oh, you just wouldn't show. Okay. All right.
All
okay.
right. Michael, thank you so much. Keep up the skepticism. Tune into Michael Shermer Show every week on
we'll
podcast.
We'll see you tomorrow, Avi. Yeah.
All right. All right. So Avi and I are going to continue for I have another 10 minutes if Avi does as well. So sure. Avi, still there. Good. Michael's still there, but that's weird. He's not supposed to be there. All right. Let me put in Avi. There we go. And I'm going to replace there with me. There we go. I'm going to take that off there. Okay, Avi, we're back live. Avi, if you were at are you going to the testimony next Tuesday?
No, but okay. I was asked to comment on that, so I will watch it probably from a distance.
All right, there's 4,000 people watching us right now. If you could ask a question, be promoted or demoted to Congressman Loeb from the state of Massachusetts, what would you ask these witnesses?
Well, I want to know if they have first-hand evidence. I want to understand what it is, okay? And that's my main concern, that people who talked about the subject were either hearing the story from other people or sort of indirectly hinting from documents that something might be out there, that the government is in possession of things. And I was sitting next to Eric Davis at the congressional briefing in May, and he was saying that the U.S. government has about a dozen spacecraft and also biological pilots that were recovered. And, I have no idea of whether this bears any, truth or not. And the only way to find out is to get, either clear photographs or see the actual physical evidence. And before I have that, I will just be, just like Michael, skeptical about it.
Would you take them up on an offer if they did ask you? I mean, you're very heavily astrophysical theory focused, but also sensor focused. Your multi-domain, multimodal technology that the Galileo project employs is unparalleled in this. I mean, you even use sound sensors. It's incredible. But what would you trade? Would you like to have hands-on in biologics? You're not a biologist, but they talk about non-human biologics. They talk about objects that clearly, I mean, you're one of the world's experts in relativity and black holes. You're not a one. I mean, you're published 800 papers or more, maybe that's your H index. I forget. But Avi, when you hear about things such as what David Grush has testified, that this object is bigger inside than it is outside. It has all sorts of things that always are claimed to defy the laws of physics. You're an astrophysicist. I'm a physicist. What do you make of those claims? What would you do aside from the Galileo project? You have access to people, testimony, evidence, physical evidence, and eyewitness evidence. What would you do?
Well, if I have access to the evidence, if the US government, for example, signs me on a non-disclosure agreement, which they didn't, and they show me the actual evidence, I would help them figure it out. Now, you will not know about it because I won't be able to speak about it publicly, but you will see that I'm not talking anymore about this subject. I would just like to know, you can think of me like a kid, okay? I just want to figure it out. I want to know whether we are alone. I think it's the most romantic question in science, whether we have a partner out there. And, it's a blind date, of course. Our imagination is limited to our experiences on Earth, and nature is more imaginative. So I don't want us to assume that we know the answer in advance. I want to see the evidence. And if the government has it, I'm happy to help them figure it out. But I haven't seen the evidence as of yet. And the Galileo project has 3 observatories in Massachusetts, Pennsylvania, and Nevada. And one thing I told them that in the coming months, as 3I Atlas comes close to the sun, we should monitor for any anomalous activity in the Earth's atmosphere, just in case it released any mini probes, if it's a mothership. But if we don't see anything, so be it. If it's a rock, then fine with me. I mean, if imagine being on a blind date, obviously it would be disappointing if on the other side there is a rock.
We have some questions from the audience about the actual, composition of it. So, what is the strongest evidence, of all the 4 or 5 or 6 different attributes that we've talked about? Explain, what a comet is, basics of a comet, and then how this thing differs from it for people that might not be familiar, and then which of the anomalies are most clear cut of interest to you?
Right. So a comet is basically a dirty iceberg, ice ball. And actually, Fred Whipple, came up with that idea. Before him, it was not he was at Harvard, and he went to Harvard Yard one winter and saw all these, people throwing ice balls at each other, and realized, actually, comets might be just like that, dirty ice balls. And we now know they are a mix of rock and water ice. In most of them in the solar system are like that, and they come from different distances, and we can see them erupting when they come close enough to the sun, because when they are far away, the ice remains in the ice phase, but when the ice is warmed close enough to the sun, and that's within a distance of a few times the Earth-Sun separation, at that point the ice turns into water vapor. It sublimates. There is no liquid in between, because liquid water can exist only under external pressure. So that's why there is life on Earth, because there is the atmosphere that provides pressure that allows liquid water to exist when ice is being melted by sunlight. However, if there is no atmosphere on a piece of rock that has some ice on it, then the ice goes straight into vapor, into gas form, and that is called sublimation, and that's what you see in comets. Now, the ice is dirty; it has dust particles in it. So when you get this vapor, it's it contains also some dust particles, some of which have a size comparable to the wavelength of sunlight. and in that case it scatters sunlight, and you see this glow behind the comet that is just scattering of sunlight by either the dust or the gas that comes off the comet. And we see a lot of comets in the solar system because these are the building blocks that were left over in the outskirts of the solar system, where the water ice formed. In the inner part of the solar system, there is not much water ice. Of course, on Earth, we find the liquid water because of the atmosphere that keeps it in place. But if there was no atmosphere, like on the context of Mars, all you find on Mars without a significant atmosphere is either some reservoir of water ice on the cold parts of Mars, or nothing at all. It's a desert, and that's what you find on an object without an atmosphere.
Land the spaceship here. Tell me what to expect on October 3rd, besides the Nobel Prize ceremonies, which are coming up, and you might be up early that day. But Avi, what prediction might you make for the public to judge and maybe help settle the issue, or contribute more information to the debate?
For me, the biggest anomaly, putting the trajectory aside, let's imagine it's an object on some rare trajectory by chance. Okay, it's the size of the object. Okay, and the high-rise camera on board the Mars Reconnaissance orbiter will be able to resolve 30 kilometers, and that is roughly the scale of the nucleus if it's big. And I would like to see the images coming from there. I know that the European Space Agency will also employ all of its probes. It has the Mars Explorer and some other probes, and I look forward to seeing the data from all of these probes. And if we see that most of the reflection of sunlight indeed comes from some compact cloud of dust, which we can tell, if the size is of order 46 kilometers, comparable to the size of a pixel, then, I will say, if it's a cloud of dust, then it's probably just a regular comet with a small nucleus. But if it turns out to be a solid surface of an object that reflects the sunlight, then I think we have a problem, because how can you get such a giant rock every decade to the inner solar system? That's untenable by the reservoir of rocks in interstellar space.
Now, what if it does turn out, in the fullness of time, to be just a comet? What makes it scientifically exciting still?
Oh, here is an interesting point. If we had the foresight to have some interceptor waiting for it, so that we can land on such an object, collect some material like 100 grams, the way we collected from the asteroid Bennu, and bring it back to Earth. That's a completely new approach to astrobiology. Right now, astrobiology is about looking at the atmospheres of exoplanets. I'm saying let's retrieve some material and check what are the building blocks of life there. If we find the same building blocks, the amino acids that we found on Bennu, that are the building blocks of life as we know it, we know at least that around other stars you have the same building blocks, amino acids, that perhaps give rise to life as we know it. I would like to know that is a completely new way of doing astrobiology.
Very good. Okay, so in the 5 minutes we have left or so, I want to do some rapid fire questions from the audience. So Edward asks, why would aliens disguise themselves as a comet? Why would they care?
Yeah, that's a good question. It depends on their intent. So, when you go on a blind date, you never know what the other side is hoping to accomplish. And it could be exploration. It could be that they go through planetary systems, the habitable zone of planetary systems, for a reason. Or, for example, it could be that it represents the dark forest hypothesis, which is a solution to Fermi's paradox. When he asked, where is everybody? One solution is the aliens are not very far from us, but they are quiet because they are worried about predators. And when they see us evolving technologically, they would like to visit and either figure out exactly what's going on, or maybe even pose a threat to humanity because we endanger them. So you never know your neighbors until you see them.
That's right. Well, my wife knew what my intentions were on the first date. But Avi, tell me about the glow Tom Colby is asking that came from in front of the object.
Right. So that is very puzzling because what happens usually is you get the glow from dust particles that have a size comparable to the wavelength of sunlight. So they scatter sunlight very effectively. But for the same reason, sunlight pushes them very quickly. I calculated within a day, they should have ended up behind the object. And so that's why you see a cometary tail usually. So it's either, the cloud of the plume of gas being pushed by the solar wind or the dust being pushed by the solar radiation. In both cases, you end up with a plume of gas stretching behind it like a trail. And that's the origin of cometary tails being pushed away from the sun. Now, we don't see that here. So what could be the reason? It could be that there is not much dust. It's what we are seeing is reflection of sunlight from ice. Water ice primarily, because CO2 ice can get evaporated very quickly. So the only remaining ice that can go a distance is water ice. And then this water ice is evaporated from the front, the sun facing side of the object. So you see it when it scatters sunlight, but then it gets evaporated at some distance and it doesn't go behind the object anymore. So then you get a preference ahead of the object towards the sun.
Carl Rollo asks, how did it get past the heat bubble of our Oort cloud? So this is a general comment. Forget about if it's a comet or I don't know, it was a little Freudian slip. I said comet, not comet. But just ignore that it's possibly technological. How could a comet get through the Oort cloud is what's being asked.
That's a great question. Space is mostly empty. Yeah. And I actually did the calculation because this object is going through the asteroid belt, which is actually a collection of fragments left over, from either planets that were destroyed or the building blocks of planets that were left in the solar system. We find them in the main asteroid belt, and the density of rocks there is much greater than anywhere else in the solar system. And I calculated, and it turns out that the chance of this, an object even that is 40 kilometers in diameter, the chance of it colliding with anything significant is negligible. I mean, most of the time it collides with dust particles, but they don't do much damage. And if you ask how much material does it scoop along its path, it's really completely negligible. It's much less than a millimeter, even if you integrate over billions of years when it goes through interstellar space. It doesn't collect much material because space is mostly empty. Every now and then there are dust particles colliding with it, molecules, atoms, but that doesn't add up to a lot. We are talking about of order a millimeter over billions of years.
Right. Okay. Native 95 is asking, how do you explain the high levels of pure nickel without the presence of iron? We touched on that earlier, but just a brief.
Well, one way to explain it is if there is a process similar to the industrial production of nickel alloys, and that's called carbonyl. You can find it online, and this is a process that can make that releases nickel without iron because it's nickel related, and that's how we make those alloys industrially. Now, if nature doesn't do that often because we haven't seen it before, then maybe it's a signature of industrial production of whatever surface 3i Atlas has, in which case it might be technological.
And why would they use that versus steel or something like that? Why would they focus on nickel?
Still, it will still, because that's what we use for spacecraft, by the way. What you call steel or material used on spacecraft is nickel enriched relative to iron.
Right, but there are other alloys, other compositions.
There are other alloys. Yeah, of course. So I'm just saying this is unusual. This is an anomaly relative to what you find in comets within the solar system. That's all.
Exactly. Galactic Hurricane is asking, why is it red like ʻOumuamua? Is that true?
Right. So that may well be, if it's not a cloud of dust, as I mentioned, around it that is reddening it, then it most likely is just the surface that appears red because it's bombarded for billions of years by cosmic rays. And we see that in the Kuiper belt. We see objects that are red. And what happens is that organic compounds are being made as a result of the bombardment by cosmic rays, and you end up with a red color. So Kuiper belt objects like Arrokoth, that was an object that was studied quite a lot in the Kuiper belt, they appear red. And the same was true for Oumuamua. It was relatively red. So apparently objects that are exposed to conditions in interstellar space are becoming red. It has nothing to do with political views of whoever are the passengers on these things.
Congresswoman Luna's, favorite color. All right, last question. Our friend Stephen Weiskosil asks, Professor Loeb, if 3i Atlas shows non-gravitational acceleration or anomalous spin, would you consider evaluating it not only as a natural object, but a test of coherence, which I think means intelligence? Is there some putatively natural thing like spin, but then acceleration plus spin? Is there some combination of forces? You see the golden ratio in these things. He's asking, what would you then say it's technological in origin?
Well, that's interesting. So I'm now looking into the data on the trajectory of this object. I want to find how significant is the limit on non-gravitational acceleration. But of course, at any point along the orbit, we might see a maneuver. And that usually happens for spacecraft closest to the sun. When we want to give a spacecraft the most boost, thrust, we activate the rocket effect when it's closest to the sun, because that's when gravitational assist from the sun is most effective. And so I would like to wait until October 29th and see if there's any maneuver. Of course, if there is, that would be a clean signature that we're seeing something technologically, as long as the non-gravitational acceleration is at a level that is far greater than you expect from the rocket effect of cometary evaporation. I calculated that the level of cometary evaporation of this object is very weak, and the non-gravitational acceleration is almost negligible. It will be really difficult to detect it. And so if we see something significant, a change in the trajectory that is significant, I would argue that's very intriguing.
Yeah, very much indeed. Okay, well, this has been an intriguing conversation, and I want folks to know how rare Avi is, both in terms of his courage, his bravery, but also his productivity. And that reminds me to remind you that my new book is a productivity book. So you too can take on the mantle of leadership, courage, and productivity that Avi Loeb has exhibited. These are lessons from 9 of the 22 Nobel Prize winners I've interviewed on this very show, including eminent luminaries from Harvard, from all walks of the academic lifestyle. This book is on sale on Kindle right now for the low price of just 99 cents. So Avi, you can't beat this low price. There it is there. Get your own copy. Avi, I want to thank you for inspiring me and a generation of astronomers. We'll have many discussions on this, maybe on October 4th if we're still here to tell the tale about it, right?
Thank you. I look forward to that.
This has been great. So everybody, thank you so much. Thank you to Avi. Thank you to Michael Shermer. And stay tuned. We have an interview with Thomas Hertog, who Avi knows very well as well. He's Stephen Hawking's final collaborator. That comes out tomorrow or tonight. If you're a member of the channel, don't forget to go to my website, listed down below, where you can get some high nickel, but mostly high iron from a meteorite that fell to Earth is older than the Earth itself. It's 4.5 billion years old. And once in a while, I give out a moon rock, Avi. This guy, Bart Sibrel, claims we didn't land on the moon, and he claims I'm committing a felony by having this piece of moon rock. But I'll tell that tale to the federales. No, my lawyers tell me I'm totally safe and secure. I give a moon rock out. I give out meteorites, guaranteed if you have a .edu email address if you live in the United States. So click on the link right there. Avi Loeb, thank you so much. We'll talk again soon.
Thank you.
Bye.